So MakerMask has been working with fabric masks, and there's been sort of an evolution of names for the projects that have sort of all rolled into this over time. I look back at our slides and our history, and it turns out March 9th is also when the first fabric mask prototypes that became MakerMask were developed. So that's kind of an interesting happy birthday across projects. And as a lot of the people on this call know, March 11th and beyond is when Project Fabric Masks, which has been called Project Cloth Masks and Project DIY Masks, was all incubated at Helpful Engineering. And that really, really helped bring a lot of amazing people and ideas together so that we were able to get the first sets of prototypes out for testing by March 17th. And then we're able to launch the website and get those designs out after they'd been field tested and lab tested. So we were able to have a relatively immediate impact getting masks out to people who needed them very early on. So just the website reach alone had 40,000 views by the end of March, and it was sort of explosive growth from there on for the next few months. So that was really great to kind of have Helpful Engineering to pull all these different people with different skill sets together so that we could be responsive to the supply chain shortages and a lot of things that many of us hadn't really thought about quite so intensely before March of 2020. So over the course of 2020, Project Fabric Masks and MakerMask were able to release 5 different open source mask designs. We've published a whole bunch of supporting information about the science and engineering behind the different designs. And one of the really big things that came out of that was information about the material science and sort of what to look for in different masks and how you approach the problem depending on what the target audience is. So different masks for different tasks and different population groups depending on what the needs are. And so we focused a lot of our effort on testing and sharing science information and designs, but we also spent a bunch of time in those early days coordinating donations of nonwoven polypropylene to try to get the materials to make the masks out to the people that needed them. And so that directly resulted in 55,000 masks just from the materials, but our larger footprint, we didn't track very well because we didn't have that sort of embedded in the system. We put the information out there for anybody to use, and we didn't actually have any way to track who was using it, which has kind of been interesting. And then it's been really great not only working with the group of people at Helpful Engineering, but we've also developed a community of volunteers and supporters through social media as well. And some of the Facebook groups have been really, really valuable for that. And then in 2020, we ended up reaching about 500,000 views for the website, and we're seeing continued interest as sort of the regulatory and supply chain issues change and evolve and the needs of our communities evolve. We've been evolving with them to meet that need, and that's led to a whole lot of growth and challenges and interest. So in 2021, things are still moving forward. We completed a fundraising campaign to do a bunch of formal laboratory testing, and that has been really great. We got donations from Helpful Engineering, so thank you, Helpful. And another 68 members of our community all sort of came together to crowd fund formal laboratory testing through an accredited lab. And then in February, we got 100 samples shipped out to be tested, and we are eagerly awaiting the results on that. And that's testing to regulatory standards for both US and European standards. And so that's another interesting, complicated challenge, especially in the space of masks, where you're looking at the regulatory standards for different locations and different types of masks. And so that's been really challenging, especially in terms of what the requirements are for community masks or cloth masks or barrier face coverings. The language around what we even call the masks that are mandated for use in a lot of areas around the world is evolving and complicated. And so we just got back some of the preliminary results from Nelson Labs on the breathability and fluid resistance of the most recent fabric samples. And so I had to sneak that in here because I love talking about the data. We tested both non-woven polypropylene 3-layer masks, which are constructed from SmartFab, so that it's something that is easily available and that people can get in US and Canadian markets and a number of other markets around the world. And then a very specific cotton, so Kaufman Kona cotton that was familiar to the sewing and quilting communities, along with non-woven polypropylene. And so that's 2 layers of cotton and non-woven polypropylene. And so hot off the presses, the non-woven polypropylene, even in 3 layers, is incredibly breathable. And when compared to the US medical mask standard, so that's ASTM F2100, the non-woven polypropylene passes with flying colors, but the cotton is far less breathable. And so if you're familiar with the different regulatory standards, you can sort of see how it compares. And then for the fluid resistance, which has always been one of the advantages of using the polypropylenes, the non-woven polypropylene specifically, you see that it passes the ASTM F1862, which is part of the ASTM F2100 standard for fluid resistance, whereas the cotton, non-woven polypropylene cotton combination doesn't. So that's just sort of the quickest ever overview of some of the stuff that MakerMask has been working on and that we've been working on with our community to try to make it so that we democratize access to both the information for the designs, but as well as the science supporting the different materials that you can use to construct them. So ideally, especially for people who are working towards medical device standards, these particular tests are done towards that standard and could be used by other groups who are looking into constructing masks to help inform their designs and move the field forward.